Hey guys, thank you so much for joining in. So, team, can you please confirm whether you can hear my voice and see my screen? Please respond me over here in the chat window. Okay, I can see the confirmation. Thank you, Suhail. And I can see Aditya, Satvika. Excellent. Thank you so much, team, for confirming. We'll wait for another minute and then we'll get started. So, we'll start at 7 p.m. IST. Okay. Thank you so much, everyone, for joining in for this live session. Now, my name is Nachiket Murthy, and I'll be your host for this today's session. Now, this session is presented by Manifold AI Learning. So, if I want to talk about Manifold AI Learning is an online academy with their goal to empower the learners with the knowledge and the skill sets which can be directly applied to solving the real world problems in data science, machine learning, and artificial intelligence. Now, the topic of today's discussion is MLFlow, which is an open source platform for machine learning lifecycle. So, I just want to hear from you guys. Why do you think that we require a platform to manage the machine learning lifecycle? What do you think? So we have actually live in various platform. So I can see some personal messages as well as the messages from the various other platform. So I want you to let me know, why do we require a platform which is required for me to manage this machine learning lifecycle? So I can see a response from Aditya. Aditya says that it's actually required for managing the complex machine learning project. Okay, that's correct, Aditya. And I can see a response from Savita. Savita says that, sir, it is required for us to perform and track the artifacts. That's also correct. And I see another response from Saurabh. Saurabh is saying that, sir, it is required for me to uh, track the data set and ensure that we store the model in a right format. Excellent. So, what are your other thoughts, team? So, what do you say? Okay, I can see few more responses as well, which is along the lines as which will help me to track the experiment and which is going to help me to. Okay, most of the responses that I see here, it's about the tracking the experiment. That's correct. See, when we talk about machine learning, so when I implement any machine learning model, or when I think about the uh, writing the code for uh, like writing the code for a machine learning project, so here In case of machine learning is not just about all the software code. I mean, obviously we will do the coding. We'll be using the various programming languages. We've got Python, we've got uh, various programming languages. Using the various programming language, we will write the code. But machine learning is not just about the software code. Now, when I talk about the machine learning, it's a iterative approach. Here, when it comes to creation of a model, we'll be taking up an iterative approach. Now, when I say iterative approach, this would involve the hyperparameter tuning to find the best model. This would involve retraining my entire model whenever there is a change in training data set. And when I change the data set, a new model will be generated, which means a new artifact will be generated. And this has to be tracked as well if the data changes. So you will have to track the model file, preprocessor file, validation file, along with the code. If you have done some changes in the way that you have processing the data set, then you have to track the software code as well. Now, when you're working in a large scale project, it is easy to lose the settings of the best performing model if it's not closely monitored. And that is where the requirement of the platforms such as the MLflow will come into picture. So MLflow is a platform that would help me to manage the complete machine learning lifecycle. It's a platform that would help me to manage the complete, that is the end-to-end machine learning lifecycle. So what exactly is this MLflow? Now, when I say MLflow, it's an open source platform which is there for us to manage this ML lifecycle. This would include the experimentation, reproducibility, deployment, and it also has a central model registry which will help me to track my entire machine learning lifecycle. Now, to help us to do all these things, we have various components in MLflow. So, some of the important components in MLflow are the MLflow tracking, the MLflow projects, MLflow models, and model registry. So, these are the important components of an MLflow. If I talk about this MLflow tracking, this is a component in MLflow that would enable me to record and query the experiments. So here, when I say record and query the experiment, this would allow me to track my code. It will help me to track the data, configuration, as well as the results. So it would help me in better tracking the same. And we have got another component that is called as the MLflow project. Now with this MLflow project, I can package my data science code into a format which will ensure that it will always be reproduced on any platform. So what it means is, let me just give you a real time scenario. Let's say as a senior data scientist, you are going to write a code and you have actually performed some pre-processing on this given data set and you have shortlisted a machine learning model. Now, what you want is you want your team's help in performing the hyperparameter tuning. Let's say in your team, you have got three data scientists who is working in your team. Now, you would require their help so that all of you can divide the work and find the best possible hyperparameters for the model. Now, as I mentioned, you have done your code as a lead on your computer or in your laptop. Now, how do you ensure that all these three people, that is, all these three data scientists who are part of your project, is able to use that code? Well, that is where this ML projects would come into picture. It would help you to package their data science code in a format which can be reproduced on any platform. Like, for example, you can host or you can put all the source code into a GitHub and you can directly run this MLflow project directly from the GitHub itself. So that's the benefit that we have got when we are working with this MLflow project component. We also have the MLflow models. Now with this MLflow models, you can deploy the machine learning models in a diverse serving environment. And it also has a centralized registry, which we call it as a model registry. Now with this model registry, you can store, annotate, discover, and manage the machine learning models in a centralized repository. Now, with this model registry, you can set which model that you want to use in a staging environment, and which version of the model that you want to use it in a production environment. If the model is working as per the expectation, it would help you to transition from the staging to the production environment all over here with the help of the single platform of this MLflow. And using this MLflow, you can deploy the models in any cloud platform. So those are some of the key things that you need to remember, and the advantages that you need to remember when we talk about this MLflow. If I want to talk about some of the features of this MLflow, so this MLflow, as I mentioned, it offers the data scientist the flexibility to conduct the numerous experiment before you move that model to the production environment. And not just conducting the experiment, it also tracks those experiments, and it is easy to track. It records the crucial model evaluation metrics. We can decide what are the evaluation metrics that it has to log. So we can control, and we can specifically say what are the metrics that it has to log. It can log such experiments. And it also maintains the log of hyperparameters which were employed during the model development, and it facilitates the storage of the trained model in conjunction with the optimal hyperparameters, and it would empower the users to seamlessly deploy the machine learning models to the production server or the cloud environment as well. Now, one thing that I wanted to highlight, guys, when you're performing the training, so we can set up our own requirement and we can perform the training in our environment that we would specify. And this MLflow also gives me the flexibility to train my model inside my own custom environment, which I can create it inside my Docker environment. I can create my own Docker environment, which is not like which I cannot directly set it up. So to have a replaceable environment, I can create a Dockerized environment and I can train my model over there. And not just that, this MLflow allows for the monitoring of the model in both staging and the production. This would ensure that all the team members stay informed. And whatever the logs that we would maintain, we can push those logs into a database like a MySQL database or any such database, so that we can connect this database to any other visualization tools like Power BI or Tableau to create a visualization and to create a dashboard to clearly see what is happening in the model that I have got. Now, the question that comes to anyone's mind when we talk about MLflow is it compatible with the current workflow, which every data scientist is familiar with? Well, let me tell you, MLflow has got an amazing versatility. With its versatility, so it makes it compatible with various popular machine learning libraries like scikit-learn, keras, tensorflow, pytorch. It supports all the popular machine learning libraries, and this supports the multiple programming languages. And whatever the model that we would build, it can be accessible with a REST API as well as the CLI, that is the command line interface. And when it comes to the integration of the existing code to your MLflow, it's a pretty straightforward process. Now, where do you think this ML flow will be used? So I can say that the ML flow is better suited when you want to compare different models. So when you have got different models, so when you want to compare different models, that's when you can make use of this ML flow. Or when you're working in a cyclic model development, where you want to push the models reliably to a production environment with the changes in data or requirements, or whenever there is a decrease in model's performance, in such scenarios MLflow is preferred. Or when you are working in a system where you want to ensure that the dependencies are always taken care in a large project, that's when the MLflow is preferred. Or when you're working with large data science team, so definitely that's one of the use case of the MLflow. Now that you have got a clear understanding and the benefit of using this MLflow, let's see how we can get started with this MLflow. So in order to get started with this MLflow, we'll take up a hands-on approach. What I'm going to do is I'm going to launch a VS Code, okay, and we'll start coding from there. Here, for the demonstration purpose, I'll go ahead and create a folder just for the demonstration purpose, and I'll be sharing you this link at the end of the session. Okay, so what I'll do is, to begin with, I'll create a new repository here itself. Okay, so this is the repository that I've created. So I'll be sharing you this repository link at the end of the session. For now, let us proceed ahead. So what do we have to do if I want to get started with this MLflow? First thing is, obviously, you'll have to install this MLflow. So I'll just create a requirements.txt file. I've just mentioned the dependency as MLflow. Now, in our learning journey today, we'll be taking up an example use case. For that specific reason, will also require the NumPy library, Pandas library, as well as, let's say, joblib library in case if I want to serialize something. Okay, I think these are the sklearn library, that is scikit-learn. So these are the libraries that I'll be requiring. So what I'm going to do is, I'll start by creating a new environment. The way that I would create a new environment is, let me just get some example data so that I'll show you the same. So we'll just run these commands. Okay, this would help me to go ahead and set up the virtual environment. So for this demonstration purpose, I'll say MLflow demo env. That's the environment name that I'm going to create. We'll activate this environment, and inside this environment, we'll go ahead and install whatever that I have mentioned inside this requirements.txt file. So I'll launch my terminal. I'll go to the folder of MLflow demo live. Okay, so I'll just go ahead and first create a new environment. I'll say -y so that it can go ahead and create the environment. -y means whenever there is any question, it will be directly marking it as yes. Okay, so this is going to create a new environment. Once the environment is created, I'll go ahead and activate this environment. I'll say MLflow demo env. So this will activate my new environment. Now, by being inside this new environment, I'll install whatever that I have mentioned, the dependencies. So in pip install -r requirements.txt. So this would go ahead and install everything that is required for me to work with this MLflow with our use case today. Okay, so what I have done right now is, I've created a new virtual environment. Now inside this virtual environment, we went ahead and set up some setup, that is the installed some of the important libraries which we require for the demonstration purpose. Now what I'll be showing you is, we'll take up a tutorial that is present in the MLflow page itself, and I'll I'll show you as how easy it is to work with this MLflow, and I'll help you understand, okay, what is happening over there. I'll tell you in a step-by-step manner. So just I'll start by creating a new Python script. Now, whenever we are working, okay, in a production environment, we generally prefer to work in a Python script format. The reason, because by creating a Python script, we'll be able to modularize the code. So I can separate the files for pre-processing. I can separate the files for training. So that's a general practice that we use it whenever we are working in the production environment. So I'll start by creating a new file. I'll say train.py. Okay. Now I'll start by importing the necessary libraries. So I'll say import numpy as np. Then we'll also import pandas library. Then once I import this pandas, so we'll go ahead and train a model. So we'll take up an example data set, which is a wine data set. So for that specific reason, it's a regression task. So I'm going to import a model. So let's say Elastic Net model. Okay. So this is going to import an Elastic Net model. Now, apart from that, so once we have performed the activity of fit of this model, we want to generate the prediction. And after the generation, obviously, one thing that is common that we have to do is generation of metrics. So we'll load the metrics, which is required for validation of my regression model. So I'll say from sklearn.metrics, I'll be importing the mean absolute error, and I'll say mean squared error. Okay, and we'll also import the R2 score. So these are the metrics function that I'll be importing right now. Okay, so once the necessary import is done, so since we are working with this MLflow, I'll say import MLflow. Okay, I'll say import MLflow. Now once the MLflow is imported, here when someone tries to run this script of this train.py, so I want to do some certain task. So if someone tries to run this Python script, then the way that we would mention is if underscore underscore name underscore underscore equal to underscore underscore main underscore underscore. That means whatever that I write inside it, that will be executed when someone runs this Python script. Okay, we generally mention it when we have multiple functions inside a Python script to give a direction as from where the execution to start. We will mention it in this way. So I'll start by specifying my data set. So here for the demonstration purpose, I'll get my URL. So this is the URL that I'll be referring for loading the data set. So this is the URL which says http raw git user uh, GitHub. From this GitHub, I'll be loading this data set. So what I'll do, I'll just say data is equal to pd dot read underscore csv, and I'll be reading this data from this CSV URL. And here, this data that I have got, this is separated by this character. Okay, this is how I'll be creating a data frame. Now, if I take you to this link, this is how my data set would look like. Okay, we've got various columns in this data set like fixed acidity, volatile acidity, citric acid, residual sugar. So like this, we've got various columns in the data set, and the last column that you see right here, that is the quality, this is my target column. And if you observe, each and every value is separated by this character. Hence I've mentioned the separator as this character, which would help me to read this data as a data frame in an effective manner. Okay, this is how my data set would look like. Now this will load my data set as a CSV file, as a data frame. Now once I load this data set as a data frame, so the common thing that we will do is we'll separate our x and y from the data set. My x is nothing but data dot drop columns is equal to quality. Okay, so that will be my x, my y is given by data column of quality. Now, once I separate my x and y, so obviously we'll be interested in splitting the data into two parts. So I'll do the import from top. So from sklearn dot model underscore selection, we'll be importing train test split function. Okay, so I'll call this train test split function and split the data into two parts. So x train comma x test, y train comma y test is equal to train test split. We'll mention x and y, and we'll specify our test size, and we'll mention some random state for the repeatability. So this will split my data set into two parts. Now, once I split the data into two parts, the next thing that I'll do is obviously we'll go ahead and instantiate our model, and we will generate the prediction. Now let me just go ahead and simply write the code, and then I'll show you how easy it is to include the ML flow into my code. So I'll simply go ahead and mention in this format. I'll say LR is equal to elastic net. Now elastic net has got the values, like for example, I can say my alpha is equal to 0.5, and I can say L1 underscore ratio, which is the hyperparameters. I'm just specifying some values as 0.5. Okay. And I'm also using some random state to ensure the repeatability. So I'll instantiate my model. Okay. Then we'll go ahead and perform the fit on this data set, that is X train comma Y train. Once I perform the fit, we'll go ahead and generate the prediction. I'll say predictions is equal to lr dot predict. Now here I'll say my x test, and this will generate the prediction. Now after we generate the prediction, so what we generally have to do, we are generally interested in generating the metrics. So to calculate the metrics, I'll mention it in this format. So we'll calculate the uh, RMSE. Okay. Then I'll say MEAE, that is mean absolute error, and I'll also calculate the R2. So these will be written when I call a function. Okay, these will be written when I call a function. I'll say evaluation metrics function. And for this evaluation metrics function, this would take two things. One is my y test as well as my predictions. It will take two things, that is y test and prediction. So let us go ahead and define this evaluation metric function. So I'll just come at the top, and here I'll define a function def evaluation metrics. This will get my y test and y pred. Okay. So the way that I'll be calculating the metrics inside this function is I'll simply say RMSE is equal to mean squared error. Okay. So I'll say y test comma y pred. Since I want to calculate the root mean squared error, I'll just say squared is equal to false. So this is going to return the mean squared error, a root mean squared error from this mean squared error function. Now to calculate the mean absolute error, I'll say MAE, that is mean absolute error, and I'll send my y test comma y pred. Okay, now to calculate my R2 score, I'll say R2 is equal to R2 score, and for this I'll send my y test comma y pred. So what I'll have to return, I'll have to return the MSC, MAE, R2. Okay, these three values which I'll be returning from this function will be stored inside these three variable. Okay, I'll get the metrics. So once I get the metrics, so let me just go ahead and print it. I'll say print, and I'll say RMSC is, I'll say RMSC. Okay, we'll copy paste the code, and I'll say MAE is and MAE, and R2 is R2. Okay, this is how I'll be interested in printing the output like this. Okay, so let's do one thing. Let's see if my code is working or not. So to test the code, I'll come back to my terminal. I'll just say Python my train.py. So if I press the enter key, this would perform the training. This would load the data set, split the data into two parts, then perform the training on this given data set, calculate the metrics after it generates a prediction, and this should print the metrics over here in this command line interface. Okay, so here it says there is a typo. Okay, so I think yeah, during the fit it looks like there is a typo. Let me just fix that. Yes. Okay, let me come back and run it again. Okay, it says MSC RMSC. Yeah, this is RMSC. Okay, let us fix that. Perfect. So I've got the output over here. It says RMSC is 0.7199, ME is 0.58, R2 is 0.121. So what I have done the implementation is, it's the basic implementation of training any machine learning model which you would generally follow. So on top of this, maybe you'll do the some pre-processing on the data set, and then you'll do some hyperparameter tuning. But this is how you generally apply any machine learning on any given data set, isn't it, guys? So what do you think? Are you able to follow with me till here? Do let me know. Okay, I see Rakhavendra, I see Rakshit, I see Dheeraj, uh, Sudarshan, Aditya. All of you are saying as yes. What about others? Are you able to follow along with me? Okay, I see few more confirmation as well. Sanjeev, Samyak, okay, Vallabha. Excellent, guys. I can also see the confirmation from Darshan. Okay, so thank you so much, team, for confirming. And even I can see the Suhail confirming, Surendra is confirming. Okay, thank you so much, team, for your confirmation. Excellent. So I can see the confirmations coming, which means that you are able to follow along with me. So what I can see right now is I've been able to implement it on my given data set, and it's a straightforward process, at least what we have done. Now, how do I implement it with the help of this MLflow if I want to track the experiment with the help of this MLflow tracking? So if I want to track the experiment, what I just have to do is wherever I want to track it, I'll just have to say with mlflow.start run. That's all. So if you look into my code, I'm performing the training right here, right? So before I perform the training, I'll just say with mlflow.start_run. Okay. So just go ahead and mention this, and whatever you want to do, go ahead and mention it inside this with mlflow.start_run. Okay, once you mention it as with mlflow.start_run, so you are saying that hey mlflow, please pay the attention. Now when this run is happening, okay, when this run is happening, so let us assume that you have performed the training, so like you have performed the fit of this model. Now if I want to go ahead and log the parameters of my model for this experiment that I have conducted, then the way in which we can log the parameters is, I'll just mention it right here. I'll say mlflow dot log underscore param, and I can mention the values of the parameters that I've used. In this case, alpha, and here the value that I have used is, I'll just write it like this. I'll say alpha is equal to 0.5. Okay, to give you an example, L1 ratio is equal to 0.5. Okay, so I'll say alpha is equal to alpha right here, and L1 ratio is equal to L1 ratio. Okay, so I'll say mlflow.log parameter. If I want to log something inside my mlflow tracking, I'll have to track the parameters, or I'll have to log it in the format of key value pair. So here the key, I'll mention it as alpha, and the value that I want to save is also the variable name of alpha. In the same way, I'll log another parameter of my model, that is my L1 ratio. I'll be saving it under the key of this L1 ratio. Now, in case if I want to log the metrics as well from this experiment that I've conducted, I can simply say mlflow.log underscore metric. Okay, and here I can say my metric name is RMSE, and the value that I want to save is RMSE. In the same way, I can log the metric. So MAE, I'll be logging this MAE. Then R2, I'll be logging this R2. So I'm logging the experiments, that is this particular experiment's parameter as well as the metric. And the best part is I can also log the model that I have actually used in this particular model, that is in this particular experiment. If I want to log the model, so as I mentioned, MLflow supports various library models. So in my case, I'm making use of the scikit-learn model. So I can say mlflow.sklearn, dot log underscore model. That's the function that I'll be using. And here I'll have to mention the I'll have to mention the variable that I've got, that is LR, followed by the name in which that I want to save. For example, I'll say model. Okay, in this way we can log the model as well. Now, apart from model, in case if I have any artifact with me, then in such scenarios I can also log the artifact as well. If I want to log the artifact, I'll say mlflow.log underscore artifact, and I can log that particular artifact file, like for example file.txt or something. So in this way I can log the artifact as well for each and every experiment that I would conduct. So if you observe closely, I haven't done any changes in the way that I have implemented my machine learning. It's still the same. Only thing is I've just enclosed it inside my mlflow.startrun. Okay. And then after that, I've just logged these parameters, metric, and the model. That is what I have done. That's all, guys. Now, observe the folder structure. I have this train.py. Now, what I'm going to do is this time I'll come back. I'll rerun this Python script. If I rerun this Python script, that is python train.py, this would perform the training and I've got the output. Now, if you come to this folder structure, there's a new folder created, that is ML runs. Okay, the new folder created, that is the ML runs folder. Now, if I expand this ML runs folder, so there is a folder 0, which is a default. And if I go under here, there's a value which says 5D something. So this is actually a particular run ID of this MLflow. And under this, there are folders like artifacts, metrics, params, tags, all these things that you see right here. If I expand my artifacts, there is the model. So this is actually the pickle model, which is nothing but the train model that is saved. And under this conda.yaml, it basically says what are the configuration, what exactly is the configuration in which the model that have actually trained. So it says if someone wants to run this model, he or she should have the MLflow version, Cloud Pickle version, NumPy, packaging, YAML, scikit-learn. These are the version that that they have to ensure that they have it. So since we have it in the YAML file, we can directly install that environment into our local system. That's how easy it is when we log the model with the help of this MLflow. Now, apart from that, so it has created the Python env file, which is the Python environment in case if I want to use it. And there is a requirements.txt file, which basically itself has created a requirements.txt file, which will be used whenever it is setting up my build dependencies. Okay, so that's the best part of logging this model with the help of the MLflow. Now, if I expand my metrics, I have a metric called MAE. So this is basically the metric that I've got, that is 0.580. I think this is a system time. Okay, I think this is a system time. And we have the R2 score, and we also have the RMSC. Okay, so the same values that you see right here, this is saved in this under the metric. And I have also logged some parameters. So if I open this params, I see alpha and L1 ratio. So everything that I've used as part of my current experiment is already present over here with me inside this ML runs folder. Now, not just we can view it in the folder structure, we can also go ahead and open up the UI. So there is an MLflow UI which is available to us. In my CLI, I can simply run as MLflow UI. So if I run this command of MLflow UI, this is going to start my MLflow UI under the local host of 5000. I'm going to launch a browser. And if I go to this port of 5000, and if I open it and show it to you, so this is the run name which has been assigned in a random manner. And for this run name, it says when it was created, what how much duration it took, and what is the source from where this model has been trained. This has been trained from the script of train.py. I can expand this columns and display all the columns right here which I've got with me. See, now it says about what is the type of model that I've used. This is an sklearn model. The values, that is mean absolute error, R2 score, RMSE, alpha, and so on. So all this information that we are able to see right here under this experiment. Now for the demonstration purpose, I'll do some changes on this Python script. So this time, instead of 0 0.5, I'll just change one of the value to 0 0.7 and the other value as 0 0.4. I'll just save it. Once I save it, I'll go ahead and run the same. So I'll start a new terminal and I'll say conda activate. Here the MLflow demo env. Okay, MLflow demo env. Now by being in this environment, I'll just say python train.py. So I've ran one more experiment on this Python script. If I come back and open up my browser and refresh this page, see, a new run has been captured. If you compare right now, so it says with the new configuration, the mean absolute error is greater than my previous value. So which clearly means that my first model was better than my current value. See, it logs each and everything. Now the best part is, if you select any of the run ID, you can see the artifacts which I've shown earlier. You can look into the metrics. You can also look into the parameters as well. Okay, now apart from that, you can also create the visualization. You can configure the chart. So here by default it has configured few chart. It is going to compare the mean absolute error between two runs. Okay, and then this is comparing the R2 score between two runs, RMSE between two runs, and so on. So all these things are being given to us from this MLflow user interface itself. So this is about the tracking of experiments with the help of this MLflow. Now once I'm satisfied with the tracking, if I want to register the model to my with the help of my model registry, then I can go ahead and click on this registered model. I can create a new model. I'll say example as a model name. I'll click on register. Okay, so this model has been registered with the version as v1. And if I click on the models right now, we've got a model that is example, and this is my latest version v1. If I click on that specific version, currently it is not in any environment. I can now move the stage from none to the staging. I can transition this new environment to the new environment, let's say staging environment. Okay, now I can go ahead and conduct the test on the staging environment, and then I can move it to the production environment as well. So in this way, we can go ahead and move the models. Now, if I click on the models, it says on the production environment, version 1 is actually running. So that's the usage of this model registry. Okay, so we have looked into the two major components. One is MLflow tracking and the model registry. Now, let me introduce you to the other component that I described earlier, that is MLflow project. So when I say MLflow project, what it means is we can create a file called ML project, and inside this ML project, we can define the overall information about this project. So for example, I can mention my name, like for example, I'll say loan prediction, or in this case, yeah, this is actually wine quality. Okay, we'll specify the name in this ML project, and we'll have to mention the environment. I'll say conda env. That's my environment. I'll say conda.yml. That means we'll have to create an environment file as conda.yml. Along with that, we'll have to define the entry points. In my case, the entry point over here, I'll call it as main. And inside this main entry point, the command that I want to run over here is python train.py. Okay, in this way, I can specify the entry point over here. So as I mentioned, for this ML project, we'll have to mention the project name, the environment file. In my case, I'm mentioning the environment file as conda.yml. So let's go ahead and create it. Now in this conda.yml, we'll have to specify how does my environment would look like. Like for example, I can go ahead and mention, like I can mention the name as wine quality. Okay, I can generally we use the channels as default, or you can also make use of the conda as well. Okay, then we'll specify the dependencies. Now for this, I'll make use, okay, under the models you can see the model as well. Okay, so what I'll do is, yeah, so I'll select any environment. If I observe this, okay, under uh, let's use this conda.yml. So here we have got the dependencies, right? I'll just copy this dependency section and paste it on my conda.yml file. So this is the dependencies to run this ML project. Okay, I can create it in this format. So once I create an ML project with my environment requirement as well as the entry point defined, so we'll have to push the code into a GitHub repository. Let me go ahead and push the code. I'll just say push MLFlow. Okay, so I've pushed the code to my GitHub repository. So I'll be sharing you the GitHub repository over here in the chat window. Okay, so I've posted the GitHub repository link in the chat window team. You can use the same. Now, what I can do is, since I have this MLflow demo lab, the code which is pushed into my GitHub repository, now I can go ahead and run this project by referring the code from this GitHub repository. Okay, that's the benefit of this MLflow project. So now what I can do is I can simply say MLflow run, and I can mention this GitHub repository link. So what it will do is it would fetch the latest code from the GitHub repository, and once it fetches the code, it would go ahead and set up the environment as per this conda.yml. And then once it sets up the environment, then it would go ahead and execute the train.py file as per the entry point that I have mentioned right here. And you can see that a new run ID has been created. Now we can come back to our MLflow UI. So let me just show you this MLflow UI right now. If I take you to this MLflow UI, so if I refresh this MLflow UI, see, a new run has been created. And if I come to my table, it says the source is MLflow project that is from the GitHub repository. So that's the benefit of this MLflow project file. We can run the model. Okay, we can actually run the model. We can actually run the experiment directly from the GitHub repository with the help of this ML project. So what we have seen is we have looked into the major components of this MLflow tracking. So to track the experiment, we'll have to enclose the command inside this MLflow.start run and mention what are we logging. You have looked into the MLflow project, which is basically a text file which says how does the project should be executed so that it can be reproduced in any platform. Then we have looked into the MLflow models, how we can save the model, and we have also looked into the model registry. Now, in case if I want to serve the model, so let us assume that I want to serve the model, then in such cases, we can go ahead and say MLflow serve and serve the model that I want to serve. Okay, so to give you a demonstration, I would just go ahead and specify in this way. Okay, MLflow serve. Okay, now after we serve the model, like to serve the model, I'll say MLflow serve, I'll say -m, and I'll have to mention the complete path of the file. In my case, let me pick one of the example model that I've got. Let me pick up this model. So this is the complete path of this file that I've got. I'll just copy this path. Okay, just ensure that we specify the path, and I'll be removing this file over here, which is not required. Let me just edit it. Not this. Yeah, I think this is the one. MLFlow serve. Here hyphen m will mention the location where exactly the file is present. Okay, then after we specify the same, okay, we can mention the port in which we have to serve the model. Like by default it will be served on the port of 5000. Let's see if this works, or else we'll go ahead and fix something. Okay, so I think the 5000 will not be available because my ML flow is already running. I'll just say port as 9000. Okay, I'm trying to serve the model, that is, I'm trying to expose this model as a REST API. So I'll just copy this command. I'm going to paste it in my terminal. Okay, it says MLflow models serve, guys. Okay, it's actually models serve. So here it says in order to serve the model, so it is asking me to install virtual env, so which is also one of the requirement. Let me just note this down under this requirements.txt file. Now for this example environment, I just go ahead and install the same. So since I've updated in this requirements.txt, you don't have to run it next time. I mean, when you do the pip install requirements.txt, you'll not get this error. So now it is serving. Let's wait. It is installing some dependencies. Okay, so I've got a question over here from Sunil. Sunil is asking us, which file did you run? So I'm actually running the file, which is nothing but the model file. So when I logged this, when I conducted this experiment, here, each and everything that you said here, these are my individual run name. So I have clicked on one of the run name and picked up the model file location. So what it means is, when I say MLflow model serve, so it basically means I want to expose the model that I have got as a REST API. Which model that I have to use? So to mention the same, let me just close it. This is avoiding a confusion. Okay, so let me bring up the one which we are working. Yeah, so what I'm trying to say is, if you look into the code, so serve the model. What exactly is the model? The model that is stored inside this location, that is artifact slash model. Okay, serve this model in the port of 9000. So I'm exposing this model in the port of 9000. And if you observe the terminal, it says it is listening on the port of 9000. Okay, that is what is happening right now. Now, if I want to generate the prediction, I'll just have to go ahead and generate the prediction. Maybe what I can do is, I can go to a postman, I can create a new HTTP request. I can go ahead and say it in this way. So for this URL, for this HTTP invocations, this is the URL that we use it, HTTP link, and the method is the post method. Now we'll have to send in the data. Okay, we will have to just send in the data set. So we'll have to mention it in the body, and we'll have to send it in a JSON format. So I'll see if I have any example serving that I've got. Give me a second, folks. I think I found one example. So Okay, I'll mention it in this format. Okay, this is how I'll be running the code. So here, okay, so what I can do is, I think I've got this example. So we can send it as a postman or we can post a curl request. Let me do one thing. Let me just show you the curl request. Okay, so here the port that we are using is the 9000. Okay, so it says, okay, I'll have to do some changes, but yeah, so this is how we can go ahead and do that, guys. Okay, it looks like something got changed. So that's the overall way in which that we can generate the prediction. So only thing maybe that I can think of right now is, so here the format is, it's actually data frame underscore split. I think that's the latest changes that they have done. Here the port is 9000. Okay, so now I can run this command. Okay, so I think something might have changed, guys. So that's the overall idea. So the idea is we can serve the model. So now I have my model that is listening on the port of 9000. We can go ahead and generate the prediction using this model that is exposed in the port of this 9000. All right, guys. So with this, we come to the end of today's session. So as part of your today's learning journey, you have learned about how we can go ahead and track the experiment using this MLflow. Okay, so uh, thank you so much, guys, for being so interactive in this learning journey. I'll be updating this code over here in the GitHub repository so that you can go ahead and refer at the later point as well. Now, I've got a special announcement for the learners who have joined with me today. So, like this session is hosted by Manifold AI Learning. So, I want to share you a good news that there is a coupon code which is created specifically for the learners who have joined with me. So, use the coupon code of September 2023 to avail special discounts of lowest prices on all the prices that you on all the courses by Manifold AI Learning on the Udemy page. Okay, so there are various courses that are available which are related to the practical natural language processing, statistics for data science, linear algebra, calculus, AWS machine learning certification, practical MLOps on AWS. So you can check out all these courses. I'll be sharing you the link in the chat window, and the coupon code is September 2023, SCP 2023. So use this coupon code to avail the lowest prices on all these prices, and it is valid for just couple of hours. Go ahead and make the most of the same. Okay, so thanks again, guys, for joining in. So if I've got any questions, do let me know. If you're clear, please confirm by typing as all good, and I look forward to seeing you next time. Okay, thank you, Rajitesh. Thank you, Aditya. Thank you, Dikshit. Okay, thank you, Radhika. Thank you, Samira. Thank you, Soumya. Thank you, Raksha. Thank you, Sridhar. Okay. Thanks you so much, guys.